students in this department at every level who are deeply into something about physics. And this is what we're going to be talking to you today. So, you're going to be applied into the physical sciences program. But the physical science is not really a program. We have put you into physical sciences, into which you declared a major. And your major could be honors physics, your major could be mathematical physics. We have a math, I call it math phys representative, we have an astro representative, we have a graduate from the medical biological side of things. So we have wide-ranging interests, and you can change. Right, Maya? Like, do students change their mind?
Absolutely. So if you change your mind throughout your years, a lot of the courses that you're taking from each of these programs relate to each other, so it is easy to switch programs if you need to. Definitely come and talk to us sooner rather than later, so that we can help you make those changes and make it a possibility.
Okay. Can you go down? All right, on the very first day you may be in this classroom. This classroom is used widely in the Faculty of Science. You're like, wow, this is actually 440 seats. I know because I had a test here recently, right? Or you might be in an even higher class, or you might be in a smaller group. Right? What are the first classes that you take in physics?
So the first few classes that you're taking are Phys 121 and 122. Those happen in the fall and in the winter. These courses are mandatory for all physics programs. So you will run into students that are in math phys, those that are doing biological metaphysics. You all start off in the same courses.
So maybe a student perspective on those early classes. Do you remember what it was like in math, in Phys 121, 122?
Sure. Okay, so first of all, my name is Thomas. Second of all, those courses were kind of interesting because they're a recap of the physics that you would have done in high school, but at a much deeper level. It's much more of an interaction between the prof and the students, and in my offering, I don't know if it changed throughout the years, but you had these tutorials sorry, 1 year, but we had these tutorials where you would be in groups and you discuss problems unprompted, so there would be no help from the professor, you're kind of just given a problem and you have to theory craft a solution. It was a lot of fun. Afterwards, then the prof would go into much more detail because obviously our solutions were 9% wrong. So then we get the correct answer, and then you say, okay, so why do we think about this? And it was very much an interaction between the students and the prof, which is very different from high school, where, at least in my high school, it was very much just packages and problems, and I didn't really like that. So it changes drastically, but those courses do, although they are very different from high school, afterwards all the courses are very similar to that, so it's a very nice experience. I don't know if you have.
No, it's just a really nice adjustment period. Sorry, my name's Lydia, by the way. I'm Phys Astro. It's a very nice adjustment period to kind of review what you did in high school while you're adjusting to university life. And the professors that tend to teach first year is like the same group of them every year, and they are amazing professors. A lot of students are really, really like, Eb is the big one that everyone's like, Eb this first year, we all love him. So it's a really great time.
And do you remember, so we have an alum here, do you remember your very first days?
I do remember taking Physics 121 with Dr. Richard Epp as well. Definitely one of my favorite professors. And by show of hands, who has the 5 equations of motion memorized in this room? That's phenomenal. So I think one of the memories that I can remember from 6 years ago was the fact that you don't really need to memorize them. You need to understand where it comes from, and after first year, you really get an in-depth knowledge of where do these equations come from, and you should leave that class able to derive them on your own. You don't really need to memorize them anymore. Is that correct? Okay,
Oh, yeah,
so
sure.
that's about it for me.
All right, so the very first day, you jump in, right? All right, minors. You can do a majors, let's say you decided Astro is going to be your love and your passion, right? You will find a whole whack of people who actually totally agree with you. But there's opportunities for you to say, listen, we're this super tech university, I want to go do something in math. What about math? Do you have a story about doing a minor? Are you doing a minor? Are you doing a minor?
Yeah.
All right, talk.
So I'm actually minoring in pure math, which is very much related to my major, which is mathematical physics, in which a lot of the physical structures that we look at end up being very mathematical. And I was in my classes confused. I'm like, okay, where do these functions come from? why can I use them without fail? Why do they even work? And so then I discovered my first PMath class was a mandatory class that I had to take. And then I ended up just choosing to take more and more, and it ended up enlightening me on a lot of the physical concepts that we look at in our world, which is kind of interesting because pure math is very abstract, but they actually end up coming up a lot in our physics classes. So it was a very enlightening experience to do a pure math minor.
What's your minor?
Just mathematics. So I already had a couple of the requirements because it was already kind of built into my degree, like my first and second calculus courses and like the linear algebra course were already built into my degree, so I only needed to take 7 courses. So then I went through and did all the math ones, and I found that it was really kind of helpful because I would choose ones that I knew would complement my physics learning, but I also chose some things where I'm like, I don't know, I'm gonna be an adult, I should know what a mortgage is, I'll take a finance class maybe.
So you can go and add to what you're doing. Did you do a minor or a specialization when you were here?
So I specialize in medical physics, which I'm not sure is still a specialization here, but it was cool. I think one thing that I did with my degree was I almost pursued I think it was a computer science minor or computation minor. I didn't end up pursuing that, but I took about 5 courses in computer science. I found that really helped with my co-op positions, working in various research labs. And one thing that I took advantage of was my elective space. I just took a bunch of things that were interesting to me. I took a music class, I took an Indigenous Studies class, just to learn more about the world beyond physics, because there's so much available out there for everybody.
I actually have a story here as well. I had a student come to my office about fall term, midway through fall term, and she came up to me and said, I'm really interested in doing scientific writing, but she wants to focus on physics. So we looked through all the minors offered at the university, and she ended up selecting a critical writing minor.
Interesting, yeah.
Which is something that's going to work really well with what her career goals are.
Sure. And the career goal piece is, I think, open to you to imagine. And we'll talk a little bit about the co-op experience. Laboratories are a big part of UW brand. It's get your hands on it, get in the laboratory and understand why things are the way they are. So I'm a chemist by training. We put them in the lab so that they understand this is how you make new materials. This is not, like, where does this come from? At every element that is in my classes, I said, where do we get this? Right? Where does helium come from? Oh, my student said, from the sun. Like, who, was that like a manned mission to the sun to grab, like, so you have to kind of figure stuff out. How do we do the things that we do? How do we know the things we know? And this is what this program is about. So the labs are designed to challenge you in that direction. So while some people have done labs, and maybe the next one you can talk about your astro experience.
Yeah, so the astronomy labs are pretty specific. You end up doing a lot of the general physics labs in our program as well. Like you'll do an electricity and magnetism lab, optics lab, and like we have a really interesting upper year course where you get to choose from like a pre-selected list of different labs, the ones that seem the most exciting to you. So you'll go like, oh, this seems really cool, and then you'll go, oh, my friend said this one was easy, and those will be kind of how you select those. But the third year astronomy lab was, I think, one of my favorites. You would have to come to campus at like 10 p.m., which is the weirdest feeling in the world, and then go into the observatory, which is on the roof of the physics building. So you'll end up going into like basically this little like room where they have a computer set up because they have a CCD camera attached to the telescope. And we were doing things like measuring the period of a binary star system, figuring out what phase figuring out where the moon was in its cycle around Earth based on like its size and stuff like that. Which was all really interesting. We even had one where the whole focus was just make a pretty picture, like use the different like filters and find like a nice looking picture like astrophotography style, which was really cool. And if you're really lucky, you'll have a nice TA who will let you out onto the roof to see the actual observatory itself. There's like a second observatory on the roof that's always pointed at Jupiter. It's very fun to go in there and figure it out, but you should make sure you can see because I fell down.
And so at the most recent eclipse that we had, physics just kind of went crazy. They had their own physics eclipse goggles.
None of us went to class that day.
Nobody came to class. Everybody didn't want to watch it from here because it wasn't a complete eclipse here, and we're not going to do partials like we do the full.
I'm pretty sure there was a bus that actually went down to Niagara.
There were 2 buses of dedicated physics astro students who were like, you don't understand, like this is part of class. So they all went and spent the day like, oh my gosh. I sat around here wondering what was going to happen. I watched the geese to see if they didn't notice. Incidentally, for the biologists in the room, they didn't notice. So yeah, that was my experience. But I'm glad that physics is in the new world. Every time I hear astro on the news, I'm like, oh goodness, something's happening in physics again, and they're going crazy. So aside from this, can we talk about I think co-op is next. If you can go on to the next. So, well, this is our laureate. You'll probably run into Donna. Did you guys run into Donna? Not physically, but like.
I didn't have any classes with her, but I do have a friend who's being her graduate student next year for lasers and stuff, and I've heard that her light matter interactions course is really good.
Exactly.
Yeah. So, do you have any stories? I mean, you're in the medical physics space. Maybe you can tell me about your background, because Donna's discovery impacted the world of essentially the laser development and how the interaction between that and biological matter. So, do you have something about what's your background like, and your brain scans that you do?
So my background in medical physics was mostly informed, I think, by my co-op experiences that really guided what I was interested in. So early on, I had exposure to a lot of imaging methods, which are somewhat impacted by what Donna accomplished. So I did a lot of work on MRIs, micro-CT. Currently, I'm working at Sick Kids Hospital as a magnetoencephalography technologist. That's a big mouthful, MEG for short. And I find that what I took away from my co-op experiences really allowed me to find a job that fit with my skills after graduation. And I'm just constantly learning, which I think is the beautiful part of studying physics.
I mean, they say you're going to be a student for life, and I remember hearing that when I was a student. I'm like, oh, this sounds so horrible. But then now I'm realizing, actually, like, you read the news, and all of you are like this. You're like, we can fix this, or hasn't someone figured this out already? Like, there's part of this that keeps on going, and even when you graduate, you keep thinking about this. Okay, so in speaking about co-ops, maybe do you have any stories of, this is not the co-op slide, but that's okay. This is your world of, so the co-op experience is when we take our students, we put them in the real world. They realize that what they learn in class is actually kind of required when you go out and move out there. And then when you come back, they all of a sudden realize, I understand why you're talking about this. So, co-op stories, where have our students gone, and what do you hear about in terms of physics and co-op?
Yeah, so this is interesting because I'm kind of all over the place with my co-ops. Although I am in mathematical physics and pure math, which is very much theoretical. One of my co-ops was machine learning, which I guess is quite theoretical, but it was actually for a solar company. I worked for Recurrent Energy, which is the #1 solar company in Canada, up for debate. They just told me that in the interview. I don't actually know if it's true. It was a great company though. They provided free lunch. So at that company, we actually went out to the solar fields. Not only that, they worked with other renewable energy sectors such as windmills, so I was able to go see one of those massive windmills in person, which, by the way, are utterly gigantic. I've only ever seen them from afar, but once you're actually up right next to it, they're absolutely massive. I could have gone up, but I'm scared of heights. But so my co-op put me out into the fields, looking at these solar plants, looking at their interactions with certain environmental factors. I would take it back to the lab. Well, I say the lab, it was a desk with a computer. And then I would write machine learning scripts to analyze the efficiency of the battery storages. So, I mean, you could pretty much do absolutely anything you want. That's the beauty of co-op, is that it's kind of like a trial and error or a test run for your hobbies, your interests. I personally wouldn't do that type of job again. That's just because of personal preference. I'm not really interested in that sort of stuff, but it was really good money and great people. And now my next co-op is doing research at the Perimeter Institute, and it's very different. It's a very different world. You're sitting in front of a blackboard, but all this to say that you can really do whatever you want with co-op. You can go anywhere. One of my friends went to China for a co-op. Doesn't speak a lick of Mandarin. I don't know how he survived. Props to him. I definitely wouldn't be able to do that. But you can quite literally do anything, go anywhere. that you're interested in, and also do not be afraid to try new things, because this is an opportunity to try, and if you don't like it, you don't do it for the rest of your life. I'd rather do that than spend 40 years working for a company that I absolutely hate. So that's my experience.
Before your co-op, can you talk about machine learning scripts, and is there an opportunity? I mean, a lot of students here ask about what about programming, and are there a lot of courses I can take? Can I get up and close with CS?
Yeah, I was going to mention that and then I forgot. So during my interview, something that they mentioned is that on my transcript I took 2 computational physics classes, one of which was heavily centered on solving differential equations numerically. I won't get into that, but it's basically solving these very complicated equations. Like when they say solve for x and you actually find an equation for x. Sometimes you can't actually do that, so you have computers give out a number like x is approximately equal to 2 point blah 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 blah. And so they look at that, they saw it on my transcript, and I did really well in that course, and that's actually why they admitted to me why in the interview why they chose me was because of the fact that I took those 2 courses. And although I didn't necessarily take any machine learning courses, the topics that you learn in the computational physics classes are very much related to a lot of the data analysis and machine learning procedures that you will do in the real world. And then you can also, it's highly encouraged that you take a CS 114. I don't know if it's required now. Perfect. You're also required to take a Python coding class, so you will learn how to code, at least the basics, which is really nice. And I don't know if I'm allowed to say this, but I also encourage you to take further CS courses. We were talking about minors actually, so it's perfect. I highly encourage doing a computing minor because a lot of the industry, not even just physics, we're talking anything, is heavily centered around electronics, computers, coding. We have algorithms which do absolutely everything for us, and people pay other people to make their job automatically. So you make sense of that.
Absolutely.
Yeah.
Those are all things that you can decide to at any moment in your degree, more or less, depending on where you land. What your co-op memories?
Yeah, so I'm actually finished all my co-ops because I'm graduating this semester. I did 4 out of the 5 potential co-ops. They leave it so you can skip 1 if you need to, and I took that time to do some extra courses for my math minor. I started off with software development, and I went through a lot of different things. I then ended up working here at the university because there's a lot of co-op opportunities here for IQC, building a quantum computer for the Master's Quantum Technologies program, which was kind of crazy because I hadn't taken Quantum 1 yet. But I managed to...
And you will all take quantum, absolutely.
So I ended up building this computer, and it was so fun and so hands-on, and I really enjoyed that I got to do that and work with this. And it's still used in the lab now. They've had to build a second one since, and I'm just really proud of the fact that I've still made an impact and it's still there. I then did some research and development work, which I didn't like as much because it was more desk job. And then my 4th co-op was doing research with a professor, and this was in quantum. And while this isn't co-op, I think it might be useful to mention, you can then do research projects in your last year for course credit. And it's basically a research project, right? So I'm currently working on a project regarding the Big Bang with one of our professors. It is a lot of things to talk about, so I will try not to do it now.
The 2-modal temperature Big Bang model, something. I lost it at the...
Bithermal Big Bang
There
is
you
what
go.
it's called, yes. It is Dr. F. Shorty's model that is
Okay, we'll see.
a lot of calculations I've been doing.
And do you remember your co-op from when you were here?
Yes, so I completed 5 co-op terms. My very first one was an interesting time because COVID had just hit. I think it was January 2020, and I was a little bit scared. I knew we had the flexibility to skip 1, so I had that available to me, but I ended up cold emailing basically every single physics professor in the department, and actually the one who gave me a job was Dr. Ha, who I think was in the first picture here. We worked on a theoretical model to model the selectivity of antimicrobial peptides. I'm gonna be honest, I don't remember too much. I was just really happy to be there and learn a lot. I think what I learned from that was I don't really like sitting at a desk and at a computer all day. I wanted to try something else, and that's when I completed my next co-op term at Sick Kids Hospital. This is where we worked on a project that looked at maternal and paternal diet and its impact on offspring brain development. So I did a lot of work on that project. I ended up going back there for for 2 more terms. So I did 3 terms there, 12 months in total. And we were able to publish some pretty cool papers. There's still some going out because it was a massive grant, a massive project. And it was there that I realized I love working in the lab. I love working on a dynamic team. My supervisor, Dr. Brian Neiman, actually completed his undergrad in physics here. So I think that's why a lot of people that complete their degrees here come back when they have entered the workplace to hire all of you, because they know the value of co-op. They know that you learn amazing things in class, and they're so excited to see you apply it. So the last co-op I had, just to summarize that, is I worked at Grand River Hospital in their cancer department because I studied medical physics, and I thought to myself, I should probably get an experience doing that. So I worked on a project where we were optimizing radiation treatment planning, and from that I realized I also love medical physics, and I am thinking still of pursuing that as a profession. And although I'm only about a year out of university, I'm still figuring out what it is I want to do in life, but what I think is really important is just learning every step of the way and taking that into your next steps.
It's exciting, and maybe those of you who don't know, we're going to get a massive hospital on campus 9 years from today-ish, so you still have time to get all this done, and they'll be ready to hire you. Maya, can you tell us what students do? There was mention about a capstone project and courses that they can take higher up.
Absolutely. So the course that Livy was mentioning, that's Physics 437. This is a course where students are encouraged to reach out to professors and ask about any projects that they can take on with them in the lab. So essentially this course is you're working in the lab with that instructor, you have a particular project that you're working on, so you touch base with the graduate students and the postdoctoral students in that lab. You have to do an oral presentation about your project and then a written report at the end. Some students choose to do 437A and B, which would give you credit, a full credit for that course. Livy's one of them. But you can also choose to do one of these, and we encourage students that are going into grad school to actually do this course. It gives you that hands-on experience in the lab to give you an idea of what grad school is going to be like.
Yeah, and not everybody's in the lab, and some people are going to be looking to go directly into industry or other experiences, and that's the multiple pathways. I tell students, like, keep your eyes and ears open. You will find something that you don't know exists yet that you will totally love. And you will find that, and all your people will be there.
That's another thing I actually want to mention. So something that advisors do is if you just want to bounce ideas off of us and have a conversation, we really do encourage you to come. I have a story of a student that came to my office about 6 months ago. She was really gung-ho about going into grad school, and after a conversation she realized, this isn't for me, I actually want to be in industry, and she's actually going to Tokyo, and she landed a job,
Love it.
and she starts in September.
Yeah, and all of those things happen. And so a lot of students don't remember the lectures, don't remember the labs. They remember what they did after the labs, in the evenings, with their friends, folks that are going to be their colleagues for life. So the clubs, what do you guys, the clean version of what happens?
Well, the reason we're wearing matching blue shirts or even here today is because we're both part of Science Ambassadors, which is the people who go around and, try to recruit you all. Some people call it cult recruitment. I feel like that's a little harsh. I do a couple of other things. I do Dark Matter, which is a Science and Society magazine where we make some creative writing and weird pieces like that. And then there's also Phys Club and FemPhys. I don't tend to be involved in the more out there clubs, but I have a lot of friends who are really into Tea Club, which when I ask is a club where they just go and drink tea on Wednesdays. They really, really enjoy it.
And I hear there's a cheese club and now a lettuce club. So apparently in the cheese club, it was just explained, for $10 for the whole term, you can go in and you get to taste all of these, and the winner gets to make it to the next week, and then they have 3 more, and then the winner of that makes it to the next week. And by the very end of term, there is a group consensus of the most phenomenal cheese to be having. What the lettuce people do, I have no clue.
Let me tell you what the lettuce people do. It's actually insane. Because I've been and I lost, and I was utterly humiliated. What they do, everybody gets a head of lettuce. First person to finish the whole head of lettuce plans the next meeting. That's it. That's all you do. Great community of people, love them to death, known for 3 years. But I was going to talk about another club. Since you said I had to keep it clean, it's about 10 seconds. No, I'm just kidding. Clubs are a great way to meet new people who perhaps aren't in your program. A lot of my great friends I met through the various fitness clubs. There's like the bodybuilding club. I do competitive bodybuilding, and there's like a group of people. There's 4 or 5 of us who love it. We go to the gym 2 hours every day. We keep each other on track, and so you get to meet a lot of people that you perhaps would not have met if you're just sitting in your classroom, going home and studying. So clubs are an amazing way to branch out and meet people with similar interests, but perhaps different programs.
Yeah, and from an alumni perspective, do you remember clubs or out of class experience?
Yeah, so I was on a varsity team for all 5 years, so I didn't do any clubs, but I did that because that took up a lot of my time, but I loved having that extra thing to do outside of class to like decompress, and I found that by doing so, it allowed me to perform a lot better in school. I also was able to work on campus part-time at the Center for Career Development, which you might see their booth around here, I'm not sure. So there's a lot of opportunities on campus as well if you need to perhaps subsidize your studies like I did. So I did those 2 things primarily.
Cool. Are there any questions as we're going? Maybe you can go forward. Any questions so far? We're gonna have tons of time. You're gonna be able to come on down. Sure. You have a question? Go ahead.
Basically, it's about international exchange program.
International
Comment on that?
exchange. So what about international exchange? Can it be done here within
This
physics?
program, yes.
Yeah. Can you speak to international
Yeah,
exchange?
absolutely. So we have several students that have opted to do international exchanges. Typically when they do that, they have to let us know about the courses that they're planning to take at the visiting school. They meet with a faculty advisor to ensure that it equates to a course that we have here at the university. And if it does, the student will receive credit for it within the program. If it doesn't, it could potentially be counted as an elective course. There's really that conversation that happens depending on where they're headed.
Yeah, so we have relationships with many institutions across the planet where we have students coming here for international exchange and the students who want to go elsewhere, depending on if they want to learn in English or in another language. They do have to connect with their advisors because their required program doesn't change. But let's say they're taking a second-year differential equations course, they could take it somewhere else. If that matches, that's done. If they take a course that's not quite required here, we don't know what to do with, we'll count that as an elective. And then going forward, they still need to take our courses. So yes, absolutely, that is still something that a lot of students like to do. Yes, question?
Can you comment a bit on criteria for choosing between physics through faculty of science and mathematical physics through faculty of math?
Yeah, can we talk about math phys and math phys math?
Yeah, so a lot of the difference stems in the requirements from the faculty itself. I know that a big difference that the math faculty puts a lot of emphasis on electives and making you do courses that perhaps aren't related to mathematics. I think the only one that the science side forces you to, okay, I say force, but requires you to do, well, that's the exact same, is they have to do a non-physics science. So you can choose between, okay, I see you in the back, so don't worry, I'll get your head out of it. You have to choose between chemistry, biology, or earth. In the math faculty, however, you have not only 3 language course requirements, you also have to choose, I think, 4 non-math courses. So there is a lot more leeway in the math faculty, and on the science side, it's a lot more strict with what you have to do. Also, I believe you do have to take more physics courses. Over there, it's a little bit more lax with the physics, which doesn't really make any sense because it's mathematical physics. So I think the science faculty does a much better job, not biased, not paid either, at planning your courses and preparing you for graduate school.
Yeah, I've actually heard that question before, and I've actually asked physicists, what makes this different? And the mathematicians say, this is about the tools to solve these problems. And the physicists tell me it's about the theory of the solution once you've used the problem to use it. So I think it's a perspective where they meet, but that's always a good question. Question, absolutely, if you can yell. Engineering physics and regular physics and pure physics. So in the Faculty of Engineering, Faculty of Engineering will always be applied. It's not a program here. We don't have an engineering physics program. It's kind of embedded within other engineering disciplines. It is always a program that is going to be an applied problem set. So I would imagine that, and if you have this program, it would be something along the lines of you are going to have to apply the physics principles to a defined outcome. They always talk about constrained problems, right? So that is the engineering way. Where I think what we're doing here is we're talking about wider problem sets. Yeah.
Yeah, I have friends in engineering, and when I look at their problem sets, it's very much just like find the torque, find this numerical value. Well, in my assignments, it's like derive this equation, or see this guy over here would be like use this and solve the equations of motion. So it's not really numerical, while the engineers focus on numerical solutions.
Good. Okay, can you go forward to the next slide? Let's talk about.
Yeah, no, anyway, just speaking of physics really
Absolutely.
quickly. Physics, you reach a certain point where people will start complaining if you need calculators for tests because they don't want to see numbers on tests anymore. It should be all like variables and equations and not actually finding like a set number at the end.
Yes. So everybody's got that. And so this is about the co-curricular record. Yes, you'll graduate, you'll have a set of grades for your curriculum that you've taken. What you've done on the side, whether you have been doing part of clubs, varsity teams, and all the rest, is part of what this ideal scholar idea is. So we have individuals who win medals, who walk across the stage because they have demonstrated leadership when they were an undergraduate student. What have you done to engage with your faculty? Have you helped other students? Did you run a tutorial center? There are many opportunities. In fact, we have tutorial centers, don't we, for students?
Yes, we do. We actually have a physics tutorial center that started, I would say, about 2.5 years ago. It's doing really, really well. We have actual co-op students that work in the tutorial center and they help lead the center. They're one of our tutors, and then we also have volunteer tutors who come in and support with various courses as well.
Yeah, so if you do more than the minimum, you go to those job interviews, they've already got your grades. They're going to ask you this question that says, so what else have you done? What else have you done that's not in the classroom, right? And if you haven't done anything, well, that's a really short interview. But if you can go on and on about how you've interacted with, if you've gone to a hackathon, if you've done these challenges where you're thinking beyond just the space in the class, that's where all of a sudden you start to step outside and are separate from the other applicants.
Another opportunity we actually have in the department is our undergraduate reps. I'm going to point to Libby again. She's one of our undergraduate reps.
Oh yeah, sorry, I could not hear what you said.
Sorry.
I was like, I'm so confused.
So our undergraduate representatives kind of are the representative of each of their programs. They get a chance to talk to the student body and get feedback from them about courses or about life here on campus. The good, the bad, the ugly, really everything is talked about. And the purpose of this is for the department to be able to improve the program for everybody that's involved.
Yeah, and speaking of interviews, do you have, when you were trying to get your new job outside once you graduated, do you remember what that interview was like and what they asked you, and how much of it was physics?
I'd say maybe one question out of 15 were about physics, and they just asked me, what did you study in school? Because I think oftentimes employers don't necessarily have a physics background either. So they're more just interested in seeing what you bring to the table. So if that is physics, talk about it, right? Maybe talk about how what you learned in class will help you succeed in a certain position. So I find that it's really important to just do what you're passionate about and learn how to communicate that in an interview and show off, this is what I know and this is how I'm gonna be super great at this job.
Yeah, and certainly co-op interviews will get you practicing. And you guys, you have both had co-op interviews. So do you have a memorable co-op interview where it didn't go great or it was fabulous?
I tended to have, like, I got most of my early ones pretty easily. I did have one where I was like, that went amazing, and then they were like, no.
Was there a question in particular? Like,
None of the questions were really difficult, but they really did like to hear about any kind of, like, research or ways we went above and beyond outside of classes, where it's like, yeah, so I know you took a class about this, but what else have you done? What else are you interested in, you know? I talk a lot in interviews when they're like, you know, what kind of things are you, like, do you also do? And I'll be like, I make a lot of spreadsheets, because if you've noticed so far, I'm a nerd. But like, a lot of things like that, really want to know what you kind of do outside of just your class stuff.
Yeah, and this is, I think, speaks to that, and this is a program we're trying to promote where students can actually build this They know you're gonna get a new Waterloo degree in physics that everybody's gonna respect, but on top of all of that, you said, and here are the things where I think I've made a really big impact. And this, part of this is that initiative. Do you have?
So I had a terrible interview experience. I actually got a job interview for the Department of Defense. And even for the interview, I needed to sign an NDA to not talk about anything that was spoken about in the interview. And there was like, what?
But then maybe we should have two.
Oh, no, it's okay. I won't mention anything in the interview. But the reason why I went terrible is because I didn't know anything prior to the interview. They weren't allowed to disclose any information. So I go into the interview, they start asking me questions, and I just was not prepared. I could not answer any of the questions. I think there were 3 technicals, and I got them all wrong. Then they asked some like personal questions, and I just couldn't answer them. And so obviously I didn't get the job, shockingly. So yeah, that went terribly. But I think the interview after that I did quite well, and I did get that job. So, you know, don't worry, if you do a very terrible interview, there's always more.
And you practice. It's about practice, right?
It is about practice.
And so admission requirements down to a low 80s average, although sometimes that number kind of creep up depending on the applicant numbers we get. 2 maths, 2 physics, and English is the standard. And anything along those lines, yeah. Sorry, did I say 2 science? 2 physics, sorry, no, that's, you'll get lots of physics when you get here. 2 science, 2 math. And we'll talk about this, move forward. I'm going to be concerned about running it. There are scholarships. There are those you don't have to apply to that are merit-based. We will look at your grades, and you're going to get an email that says thank you, and here's a nice present, right? And then there's those where you could take one of the contests. Anybody doing the Sir Isaac Newton contest, do that. That's another $1,000 in your pocket. There are opportunities where you can do these tests, and you can do these experiences. Some of these are calculated for you, and we'll get more information about this further as you go on. And so we have no, this is so far, and we're going to stop here now and open the floor to questions. Is there something dying to ask? We'll also have time in a little bit. Sure, go ahead. You're going to have to speak up so we can hear you. Supplementary exam. The supplementary, the AI supplementary files, no, we do not currently run a supplementary AIF. So there's no need. I know they're like, whew, I don't want to have to do that. Anything else that you want to ask? Well, we have a math phys, we have an advisor, we have medical physics, we have others.